All right. Number 11, right, Tom? Dx over 1 plus 4x squared. All right. This one looks, right? Yeah, dx over, yeah. This one looks like an inverse tangent one a little bit, right? Like dx over 1 plus x squared would be inverse tangent x. But it's not because of the 4x squared. Well, it still sort of is. But we got to find a way to rewrite this so that it can look like du over 1 plus u squared. So what we'll do is we will go in and we will factor out this 4. How will we factor out that 4? We're going to get 4 times 1/4 plus x squared. Actually, that's not what we want to do. That's what we would do if this was an inverse sine one. What we're going to do is we're going to rewrite this so that it's just 1 plus something squared. Sorry, that's my fault. Off to a bad start because I got distracted by this birthday nonsense. What squared is 4x squared? 2x. Okay? So what we're going to do is we're going to let u equal 2x. And if u is 2x, then du is 2dx. And if we wanted it to be 2dx, we'll put a 2 up there. And if we put a 2 up there, we'll have to put a 1/2 outside. Yeah? So we end up with 1/2 the integral of du over 1 plus u squared. Everybody good with that now? And then you integrate that to become 1/2 inverse tangent of u plus your constant, or 1/2 inverse tangent of 2x plus your constant. So when I was starting out trying to factor out a number. You would factor out a number if this was like 4 plus x squared. You'd factor out the 4. But since it's 1 plus some function squared, we'll do the u substitution. And yeah, so what's your name? Patrick, right? That's your name, yeah. So Patrick and Samantha, right? But apparently you go by Sam. Is that true? Is that true?
That is true.
That is true. Great. That's what somebody told me. Anybody else take the test yesterday? Just you two? Okay. Yeah. So as far as I'm concerned, I just told Patrick that because he's here. But like, you can do whatever you feel like during this class period. Like if you want to pay attention, you can. But if you're just like gonna sit there and you gotta be in the Zoom and all that, but like you've already taken the test. So just make sure you're prepared for the quizzes each Friday. Other than that, I don't really care what you do as long as you show up. So there you go. Happy birthday to you for that. You can just ignore all of this because it has nothing to do with the free response questions. All right, number 14. Yeah, that's what you said, Tom? 14? 14. 14? Did I write it up there this time? dy over root 4 minus y squared, right? Okay. This one looks like inverse sine, except that it's got a 4 instead of a 1. Right? This looks like the integral of this would be inverse sine of y if it was just 1 minus y squared down there instead of 4 minus y squared. Those are the rules for integrals that you should know. So what we'll do, since it's not a 1, we will factor it out and make it a 1, which is what I started to accidentally do on that first one. If I factor out a 4 from 4, I get 1. And if I factor out a 4 from y squared, I get 1/4 y squared. Everybody agree with that? The square root of one number, 4, times some other thing, right? If both of those things are inside the square root, I can separate them into 2 different square roots, can't I? Isn't that a rule? So we end up with the integral of dy over, well, let's see, that's just going to be a 2 down there. And then a root 1 minus, and how could I rewrite y squared over 4? As something squared. Y over 2 squared. So if I do that, I should then be able to make a u substitution let u equal y over 2, and du will be 1/2 dy, or dy over 2. Well, do I have dy over 2? Right, that's du, isn't it? So I just end up with an integral of du over root 1 minus u squared. And that is an integral from our rule sheet, which is just the inverse sine of u. So inverse sine of y over 2 plus the constant. Everybody good there? Any questions, issues, problems, complaints? Tom, you're happy with that one?
Yeah, I got looked up, like,
oh, good. I'm glad I'm better than the internet. I feel good about that. Despite my age, I am older than the internet. So I am also older than you. That is true. Isn't that weird? I'm older than the internet, but you guys are not older than the internet. Isn't that strange? So strange. You never lived in a world without the internet. Children are weird. What did?
like you live like most of your life without us.
That's true. You have never lived in a world that I did not exist in. How do you all feel about that? That I am a permanent part of your existence. I am, yes. Other questions from the multiple choice? Because that was the only two that I got from people. Oh yeah, I got another one. Number 5? 5? We got 2 votes for number 5 in here. I'm a little concerned because that's early in the packet. Should be easy, I hope, but now maybe it's not. I don't know. Let's look. Oh, yes. Number 5, 1 minus 3y over the square root of 2y minus 3y squared. This is just a u substitution. Got to be a little creative, though. We're going to let u equal the thing in the denominator like we often do. Right? But not the square root, just the piece inside the square root. That would give us du is 2 minus 6y. Yeah? Well, 2 minus 6y is the same as 2 times 1 minus 3y. True? So now I have 2 times 1 minus 3y. And I'll put a 1/2 out in the front. Does that make sense? Yeah. So we'll have 1/2 the integral of du over root u, or that's u to the negative 1/2, right? So this is 1/2 the integral of u to the negative 1/2 du. Integrate u to the negative 1/2, and you get 2 root u. So we end up with the square root of u plus your constant. Good or no? Yeah? Tori, you good with that? Yeah. That makes sense? Wonderful. Other questions? Oh, yeah. Number 8. That's also early in this packet. On the next page here. Number 8. T over the square root of, what is it? 2t squared minus 1. I don't know what you were doing either. We'll let u equal 2t squared minus 1. So same thing as the last one. Take the thing inside the square root in the denominator and let that be your u. Du will be 4t dt. So now we have 4t dt. We'll put a 1/4 out front. We end up with 1/4 the integral of du over root u. And then that's the same integral as last time, right? U to the negative 1/2 becomes 2 root u. So we end up with 1/2 the square root of 2t squared minus 1. Make sense or no? Yeah. You sure? Okay. They're challenging. The challenge ones are challenging. I would be very surprised if anything as difficult as those was in the multiple choice of the AP test, for sure. Yeah. Yeah. There are multiple choice questions.
Can you do number 26 and then also 32?
26 and 32. Yeah. 26 says cosine squared 2x dx. So cosine squared 2x is one that we have to use the power reducing formula for to turn it into a singular power of cosine. So the formula for the cosine squared of u is 1/2 of 1 plus cosine 2u. So cosine squared 2x ought to become 1/2 of 1 plus cosine of twice 2x, so 4x dx. And then we'll just integrate. So the 1/2 can stay up front, 1/2. The integral of 1 is just x. And the integral of cosine 4x, that's like a little u substitution one, ends up becoming plus 1/4 the sine of 4x plus your constant. So you end up with x over 2 plus sine 4x over 8 plus a constant. Does that make sense?
Yes.
Wonderful. What did you say the next one was?
32.
32. Maybe. Oh, now it works. Okay. 32. Oh yeah, the integral of secant of t over 2. Interesting. This is not an integral that I would expect you to see because we didn't talk about how to find the integral of secant, which is really something that only gets covered in a BC class in a second semester of calc. So I'm kind of surprised that this did not have, doesn't say BC only next to it. I'll show you guys how to do it because why not? It's fun. First, we're going to do a u substitution. So we're going to put a 1/2 in. I'll just put a 1/2 in. Put a 2 in. So we end up with 2 times the integral of secant u du. Then you need to know how to integrate secant u, which you don't know how to integrate, which is fine because you don't need to. But the way you integrate secant u is, let's do this. We're going to multiply the top by secant u plus tangent u. And if we do that to the top, we're going to have to do it to the bottom also. Not something, like I said, not something you need to know how to do, but that's fine. We then end up with 2 times the integral of, well, let's see here. Let's let u equal this denominator, secant u plus tangent u. What would du be? That'd be secant tangent plus secant squared. Okay. Well, if you distribute out this numerator, you get secant tangent and secant squared. So that whole numerator is just your, I guess I shouldn't have wrote these. Let's make these v's, dv and v. But anyway, you end up with a dv in your numerator and a v in your denominator. So this becomes 2 natural log absolute value v plus your constant, which is 2 natural log absolute value of secant u plus tangent u, which we can write as secant t over 2 plus tangent t over 2 plus your constant. Which must be an answer choice somewhere along the way there. Choice E, it looks like. But you don't even know how to integrate secant, but that's how you integrate secant. Integral of secant is natural log absolute value secant plus tangent. Very exciting. Not a rule that you need to know. That's BC. 66 and 68? Great. All right, 66, we got 2x minus 1 dx over root 4x minus 4x squared. So this one is similar to that one at the beginning. I think it was number 5 that we did. We're going to do the same sort of u sub. We're going to substitute out the stuff inside of the square root. Which will give us du is 4 minus 8x. And we'll note that the ratio between the 1 and the 2 is the same as the ratio between the 4 and the 8 there. But if I multiplied this thing inside of here by -4, right? If I multiply by a -4 inside of here, that'll give me a -8x and a +4. So we'll do that and a -1/4 on the outside. And we'll end up with -1/4, and then our numerator is du, and our denominator is root u. And so as we did before, that's -1/4 times 2 root u plus your constant, or -1/2 square root 4x minus 4x squared plus your constant. Good or no? Hopefully that's an answer choice. It might not be an answer choice. Is it an answer choice? -1/2, yeah. Yeah, it is. Okay. Tracy. Like they might have, like, it's possible because they could have factored a 4 out of that and then pulled the 4 out of the square root, and it would have just been negative square root of x minus x squared. They didn't do that. Good with that? Everybody good with 66? Okay. 68. Right, 68. The integral of cosine theta over 1 plus sine squared theta. All right. This is another u substitution one. So we'll note that in the numerator, we have a cosine theta d theta, right? What would u need to be to just have that whole thing become du?
Sine theta.
It just have to be sine theta. Most of the time, right, we take out the whole denominator if we can. But in this case, it's just going to be easier if we just make the top du and make the bottom 1 plus u squared. Because that one is just an integral that we have a formula for, right? What's the integral of du over 1 plus u squared? Arctangent, inverse tangent of u. So this becomes the inverse tangent of the sine of theta plus the constant. So it looks like that's choice D. Does that make sense? Other questions?
Can you do number 64?
64, sure. Ooh, that one's a challenge problem. All right. Let's see if we can figure out what makes it so challenging. What makes this one so challenging? Right, our traditional u sub would make that, if we sub that 4 plus x squared, we'd end up with du is 2x dx, which we have a 2x and we have a dx, but we don't have 2x times dx. We have 2x plus 1 times dx, which is very different. Right? That's 2x dx plus dx. That's not the same thing. So we're going to have to be a little more creative here with this. What's causing the problem? It's plus 1, right? That plus 1 is causing a big issue. If I can get rid of that plus 1, this is a very easy integral. Would you all agree with that? Well,
Yes.
isn't there a rule with fractions about like doing stuff with fractions? Like if I said, what is this? You would say that it's 1, right? It's the same as this, isn't it? Aren't those the same thing? Well, effectively, don't I have that going on here?
Yes.
Yes. I could take this as one integral and add it to this as the other integral. So I can split this into two integrals, the integral of 2x over 4 plus x squared, plus the integral of 1 over 4 plus x squared. And at least that way, I know that that first integral is pretty easy for us to do. Sure. Integral of 2x over 4 plus x squared, like we just said a minute ago. We'll let u equal 4 plus x squared. Du is 2x dx. And we've got the integral of du over u. What about this one? I'm pretty sure we do this exact same integral as the first problem we did today. Is that correct?
No, the first one is the denominator is 1 plus 4x squared.
I was not. I was very close. I was almost right. Darn. Okay, so we'll have to do this one then. We'll have to factor out that 4 just like we did with that sine integral. So we're going to end up with 1 over 4 times 1 plus x squared over 4. Everybody good with that?
Yes.
All right. So now, first off, du over u is natural log absolute value 4 plus x squared. The absolute value on that's sort of redundant because 4 is positive and x squared is positive. So you add them together, you get positive. So you don't need the absolute value. So we'll get rid of it in a second. What about the other one? We're going to rewrite the x squared over 4 as what? Similarly to the sine integral that we did.
X over 2 squared.
X over 2 squared. And we'll say let's let v equal x over 2. So dv will be just 1/2 dx. So we'll need a 1/2. We have a 1/4, right? True. So I only need a half of that instead of using the full. Instead of using the fourth, I need a half. So that means I'm still going to have a half left in there if I pull the half out of it. So we'll say plus 1/2 the integral of dv over 1 plus v squared. And that should be the inverse tangent of v. And what was v? X over 2? Everybody good there? Any questions on that one?
So when we did the the v sub in this case, would it also work if you pulled out the constant 1/4 out and then you put in the 1/2 and then multiplied by 2 to still get that 1/2 on the outside of the integral?
Yep.
Okay.
That'd be fine.
Okay.
Yeah, I mean, if you don't want to simplify, I mean, I'm just looking at it as if, 1/4 is, 1/4 is 1/2 times 1/2. So I'm saying one of those 1/2 goes with my dv or with my dx to become the dv, and the other 1/2 has to stay there. But if you want to do it, where you put the 1/4 out in front and then you add in a 1/2 on the inside and a 2 on the outside, the 2 times the 1/4 will still just become that 1/2 that's on the outside. Same thing. No more than twice, probably, but yeah. Multiple different u subs or multiple different, Yep. Probably not more than 2 though. Other questions? Yeah. Yeah. 16. Sure. 16 is a good one here to look at. We got 2x plus 1 over 2x dx. So one thing that we will note here is that if I tried to do a u sub for the denominator, right, like u is 2x, so we have du is 2, we definitely don't have that. We would note, though, that there is a single term, right, 2x, in the denominator. There's just one term there, 2x. And if everything above that in the numerator is just something being raised to a power, right, just being like, you know, a variable to a power or constants included with that, you can just split this like we did that other one into two different pieces. So 2x over 2x is 1, and 1 over 2x is, well, it's 1/2 of 1 over x, or it's just 1 over 2x, right? So this integral should be the same as this. Does that make sense? Yeah. Integral of 1 gives us x, and then the integral of 1/2 of 1 over x is 1/2 natural log absolute value x plus your constant, which looks like A. Good? Yep. So anytime you have just like a polynomial or something that, you know, it could be up like powers of x to a half or something like that, divided by a single monomial term in the denominator, just divide every single term in the numerator by that term, and then you should be able to integrate pretty easily. Other questions?
70, please.
70. Oh boy. If I was 70, I would be way older than the internet. All right, what do we get? Integral of dx over 1 minus e to the x. All right, that one looks like it's going to be an issue, I think. Anybody have a good idea with that one? Or no? No? Nobody has an idea? All right, well, it'd be nice if we could take a natural log of things. We can't just take natural logs of things because that changes the functions in general. Yeah, this one's a little bit, probably a little bit tricky to see what to do. I'll just get you guys started. This is harder than anything I would expect you to have to do on the AP test. Would you say that those two things are equivalent? Right. Dx over 1 minus e to the x means 1 dx over 1 minus e to the x. So 1 minus e to the x plus e to the x should still be 1 dx over 1 minus e to the x. And then we're just going to use this same idea that we've been doing. This piece of it, and then take this piece of it, divide them, and then integrate. So this should become, well, the integral of 1 minus e to the x over 1 minus e to the x should just be the integral of 1. And then the other piece is an integral of e to the x over 1 minus e to the x. First part of that's easy, right? How am I going to deal with e to the x over 1 minus e to the x? What u sub do you want to do? So if u is 1 minus e to the x, what is du? Negative e to the x dx, so we'll put in a negative and a negative. So really, instead of having x plus, we should have x minus an integral of du over u, or x minus natural log absolute value u, written in terms of x. Everybody good there? Questions on that? Any questions on number 70? You're all good? How common is it? I would guess that there might be like one question in the multiple choice where you have to separate it. Maybe one. Maybe one. I wouldn't. No, maybe one as in, I don't know, once every 2 or 3 years there might be one. So, but not one where you'd have to add in a bunch of terms into the numerator like this one. That's more difficult to see. Other questions?
Can you also do 75?
Yeah, and 23 was sent in the chat. So let's see here. I'm very close to the page for 75. I thought I was on the page, but I'm not aware. All right, 75 is d theta over 1 plus sine theta. Then we'll go back and do 23 after that. So common thing with trig functions when you're trying to integrate them, if you have to rearrange some stuff, is to multiply them by their conjugate. So well, hopefully that works for this one. I don't actually know. We'll have to see. Yeah. Everyone would agree with that. That should be true. Multiplying by 1 minus sine theta over 1 minus sine theta. That'll make us 1 minus sine theta over what? 1 minus sine squared theta d theta. Yeah? And what will that do? What's 1 minus sine squared theta? It is cosine squared. And now what do you think we should do? There's a power reducing formula for cosine squared. It's 1/2 of 1 plus cosine 2 theta, but I don't think that's going to help us here. We're going to, once again, separate this into 2 different integrals. We're going to get an integral of secant squared theta, d theta, minus an integral of what's sine over cosine squared. Well, sine over 1 cosine would be a tangent, and 1 over a cosine would be a secant, right? So this becomes minus the integral of secant theta tangent theta. And what's the integral of secant squared? And of secant tangent? What's the integral of secant tangent? Secant. Good or no? Everyone's all right with that? The chances of that happening are very, very slim as well. It's just good, good habit, good practice to sort of be in, to know that if you've got something with the trig expression that you're having difficulty with, oftentimes multiplying by the conjugate will make it easier, because especially if it's like a 1 plus sine or a 1 minus sine or 1 plus cosine or 1 minus cosine, because when you multiply those by the conjugate, you end up getting one of the Pythagorean trig identities that you can rearrange. Everybody get there with 75? Right. 23. Ah, yeah, this is a good one. This is a good one because I can think of 3 good ways to do this problem. Yeah. And Oh, lovely. Looking at the answer choices doesn't really give me an indication into which way I want to do it. So let's do all three methods of evaluating this integral. First, the first thing I would probably do if I was doing this one is I would just let u equal sine theta. That'd make du cosine theta. D theta. So I'd have the integral of u du, which should be pretty easy. Should give us u squared over 2 plus our constant, or sine squared theta over 2 plus your constant. Good or no? Is that answer on the, or in the answer choices? Or you're supposed to have your laptop with you every day, Tom, to look at them. No, this is not in it, correct? That is not in the answer choices. All right, next thing I might do if I was trying to do this problem would be to let u equal cosine theta. And then du would be negative sine theta d theta. So I have to put a negative inside and a negative outside, but I'd be looking at the opposite of the integral of u, du, which would be u squared over 2 plus a constant with a negative in front, which would be negative cosine squared theta over 2 plus a constant, which looks similar to one of the answer choices, but it's got a negative in it, right? So that one is also not the correct answer choice. So those are the first two ways I might try to go about doing this problem. Neither of them yielded an answer choice that was in the book or on the test or whatever you want to call it. So the next thing I might do is recognize that 2 sine theta cosine theta is equal to
Sine 2x.
Sine of 2 theta. So if I threw a 2 and a 1/2, I could rewrite this integral as 1/2 of the integral of sine 2 theta. D theta. Everybody agree with that? We'd still need to use a u substitution. We'd have to let u equal 2 theta. Du would be 2 d theta, which would mean that I need to put a 2 on the inside and an extra 1/2 on the outside. So we'd end up with 1/4 of the integral of sine u du. And the integral of sine u is negative cosine. So this should become negative 1/4 cosine 2 theta plus c. And that, I believe, is an answer choice. I hope. Negative 1/4 cosine 2 theta plus c. Yep. Now, how come we got 3 different answer choices that look very different from each other? And I said they're all correct.
A different constant is.
That's one option. One option is the constant might be different. The other option is they might just be equal to each other. Right? They may just be equivalent if you tried to rearrange them. And the answer is actually that they differ by a constant. So if we wanted to look at this just for fun, because God knows you're all having so much fun, negative 1/4 of cosine 2 theta. Well, cosine 2 theta has 3 different identities for it. One is cosine squared minus sine squared. I'm not going to use that one. One is this one, 1 minus 2 sine squared theta. And another is 2 cosine squared theta minus 1. You all seen those before? Yeah, those are good. So if I were to take cosine 2 theta and replace it with 1 minus 2 sine squared theta, we'd find that we'd end up with negative 1/4. And remember that we had a plus a constant here. So plus a constant here. We have negative 1/4 plus 1/2 sine squared theta plus some constant. And what did we get? We got over here sine squared theta over 2 plus a constant. Well, that's the same thing I've got here. I've got sine squared theta over 2 plus some constant. Not the same constant. Constant is different. Differs by negative 1/4. still a constant. Good? We could do the same thing. We would just plug 2 cosine squared theta minus 1 in and then multiply by negative 1/4 and see that that one was also true with a differing by constant. Does that make sense to everyone? Oh, good. Other questions from the multiple choice? Isn't this fun? You guys look like you're really enjoying this today. Other questions? Anybody?
Can you do 77, please?
77. Sure. I could see the people in person here with this wishful thinking that nobody would say anything else. And then like watching all of their eyes sink. Somebody asked for another one. Oh man. All right. What? Joshua's cool, so it's okay. Okay. Tom says that you're cool, Joshua, so it's okay. He what? He doesn't care if you think he's cool. All right. We're looking for the equation of a curve. The slope of that curve is x squared minus 2. And we want it to contain the point 1, negative 3. All right. Yeah. So all we're going to do is just an initial value problem. Right? The slope is x squared minus 2. So that just means that the derivative, that didn't look like it. Yeah. My handwriting is really good. Yeah. That the derivative is x squared minus 2. So to find the function, we integrate. It should be x cubed over 3 minus 2x plus some constant. And then we'll plug in 1 for x and negative 3 for y. So it looks like, what does that give us? This is 1/3 minus 2, which should be negative 5/3. And negative 9/3 plus 5/3, that'll be negative 4/3. So it looks like it's y equals x cubed over 3 minus 2x minus 4/3. Choice D. Like your quiz grade.
That makes sense. It's because I forgot to have the plus C at the end. So I was like, wait, what do I do now with the initial condition?
Yeah. Don't forget the plus C when you integrate something. Yeah. It's important. Are there questions on that multiple choice?
Oh, you're gonna have these posted later today, right? For us to look over again.
I will have them posted
All
later.
right. Thank you.
Yeah. Nobody else? All right. No questions? Going once. Going twice. No more questions.